Okay. So, yeah, I just wanted to devote. I wanted to devote this week to just anything related to like exam one, and then going into week four, we'll pick back up with the lectures, and we'll see about. Hmm, I got to think about how I'm going to work it, but we'll see about Alex. Um, are you are you frozen? Hmm, hmm, strange. Okay, let me try something. Come on. Okay. And I think it works a little bit better here. Okay. Hey Google, roll a 21-sided dice.
I can only roll dice with 3 to 20 sides.
I think you did it earlier. Let me try it again. Uh, hey Google, roll a 21-sided die.
I can only roll dice with 3 to 20 sides.
Hey Google, give me a random number 1 through 21.
13.
13. Anybody get it? No? Okay, that's okay. All right, so let's look at 13. Is this a function, yay or nay? Is this a function, yay or nay?
Yes.
Yeah, right? Stop. Anybody on the call did not get attendance credit today?
Me,
Who said that?
Tassar Blanchard.
Mr. Blanchard. Okay. Let's hop over. Mr. Blanchard. I have that you're here. That's fine.
I was tardy though.
You want me to mark you as tardy or present?
I mean, it's whatever you want to do, but I just wanted to let you know.
Do you want me to mark you as tardy or present?
Present, please.
Okay. You know.
Academic honesty.
I know. That was interesting. Yeah, because I was just gonna mark you as present. It's not a big deal. I mean, it's okay. You know, it's not a big deal. Okay. Not today anyway. Oh, come on. But I could put you down as tardy if you want to.
No, it's okay. I appreciate it.
Okay, let's look at this. So I think we said yes, right? It passes the vertical line test. No repeating x's. No x values on top of each other. So we're gonna say yes here. Yeah, that's the right one. Let's check. Let's see. Hey Google, give me a random number 1 through 21. I'm gonna go lucky number 13.
8.
8. Mr. Johnson. Mr. Johnson got it. I think he's the first one. Okay. All right. So let's look at question number 8. I gotta have some prizes. I'm gonna get some prizes one day. All right. Find g of 0. Okay. Can anybody tell me the answer for part A? So when x is 0, what's the answer?
Isn't it 0?
0. Okay. Let's see. Okay. What about when x is negative 3?
That number doesn't exist.
Does not exist. Is it does not exist or is it not a real number?
I don't think it exists.
It doesn't exist. Okay. What's the difference? Not a real number means it's like imaginary. Does not exist is divided by 0, right? Okay. That's strange. When x is 4, what's the answer?
It's not a real number.
All right, because we're taking the square root of a negative, and we're restricting our domain to real numbers. Something just crossed my mind. So you know how So you know how so with the development of the imaginary number, we said that in mathematics we needed something such that when we take the square root of -1, so that when we square it we get back a -1. Since it didn't exist, we just put a label on it. I wonder, has anyone done anything where like instead of the square root of -1, you did like dividing by 0, like something like a term divided by 0. Slap a name on that and see if you can create a system out of that. I don't know if they've done that or not. I don't know. It's just seeing, can we apply the same technique to dividing by 0? When x is 4 by 3, did anybody get a result there? Okay, so I'm going to actually use my calculator here. I'm going to pull it up on the screen. Let's go here. This is good like that. Doing pretty good. Like right before you guys came on, I was like so sleepy, so I was like, okay, let me take a nap. Normally I'll game, but I was like, no, let me take a nap today. I can actually hide this so it'll display a little bit better. Okay, I'm coming, Mr. Dawson. Oh, we need the other thing. Yeah, I need the other thing so I can type in. We're saying when x is 4/3. Okay, so what I'm going to do, let's do it this way then. Nope. We can close this out, I guess. Oh no, did we just lose our page? It really looks like we did. Ugh. Alright, let's try this again. Let's go to Pearson. And we have all sorts of technical difficulties today. We're going to sign in. Here. This one. Okay. I just want to show the calculator. What question was that? I think that was number 8. Okay. So when G is 0, I think we got 0. -1, I think we said does not exist. When it's 4, I think we got not a real number. And then 2/3, okay. So my calculator in my y equals in the upper left hand corner, I'm going to click there. And I'm going to type in the function. So we have x divided by, open parentheses, or we don't actually need that. We can say square root 1 minus x squared, 1 minus x squared, closed off the denominator and the square root. Okay, so that looks like it's typed in properly. I'm going to quit. I'm going to call up this function. So to the left of the, right here, to the left of the variable button, sorry, to the left of the clear button is this button called vars. I think it stands for variables. I'm going to click that. And then to the right are y variables. I'm going to click over there. Number 1 and number 1 to call in the function we just typed in. And so when x is 2/3, 2 divided by 3. Let's hit math as a fraction. Nope. Type in exact answer using radicals. We got to do a radicals. That sucks. Okay. So we can check it with this, but that's. I think if I was on the 89, it would spit out the radicals, the exact result. 2/3 squared is going to be 4/9. So 9 minus 4 is 5/9. I'm going to have to write this one out to get the exact result. Okay. Let me start by getting a copy of the original. So this is our homework. This is week 3. (1.3) functions. This is question number 8. And all we're really doing is g of x equals, we got this 1 minus x squared, we're doing the square root that goes under x, okay? And they want us to find g of 2/3. Okay? So I'm going to plug in at 2/3, 1 minus 2/3 squared. That's inside the square root, and that's under 2/3. All right. So that's going to be 9 by 9 minus 4 by 9. Take the square root of whatever answer we get, under 2/3. That's going to be the square root of 5 by 9, under 2 by 3. So this is the same as 2/3 divided by the square root of 5 over 3. Okay. So then to divide fractions, we do keep, change, flip. So this is going to be the same as 2/3 times 3 over the square root of 5. And then notice that the 3's cancel. This cancels this. I'm going to rationalize. We get 2 over the square root of 5. And if we rationalize by multiplying by 1 in the form of root 5 over root 5, we'll get 2 times the square root of 5 over 5. Okay? So then we can actually check this answer at least against the answer that we got earlier. We can say 2 times the square root of 5 divided by 5. And we should get the same decimal. Okay? So that one was a little bit involved. Let's hop back over to here. Exact answer. First, I want to do our final answer. So we got 2 times the square root of 5 over 5. Okay. I feel like there should be questions on that one. Okay. So I don't need this anymore for right now. I can also put you back, my friend. Hey Google, give me a random number 1 through 21.
Here's a random number, 5.
5. Okay. 5 is too late. All right, let's go to question number 5. I'm glad y'all like that game because I wasn't even gonna do it, but then y'all seem like y'all ready. I was like, okay, we can play. I think it's important to play though. Like I feel like as we get older, that energy is lost, and so we take everything so serious. And then next thing you know, like we blink our eye and like we're just miserable. At least if you could find some light or joy, or find some way to enjoy whatever it is you either have to do or you want to do. Perfect. Hopefully, you could find a way to get paid doing what you love to do. But one of the trains of thought is that the application, like when you actually get into the test or whatever it is, the real application, you just forget to play. But it's actually the same energy as play. You just forget that you're playing, and that's really like what it's supposed to be. But it's not really like that for us in this day and age. Determine whether the following equation defines y as a function of x. Okay, so this is going to be the top half of a sideways parabola. Notice we don't have a plus or minus. So, yeah, this is going to pass the vertical line test. I'm just going to say yes, all right? All this is going to be the top half of a sideways parabola that we move to the left 37 units. Okay. So that's why I kind of go out of my way to try to invoke the energy on some level. Hey, Google, give me a random number 1 through 21. I'm going to go 9 this time.
17.
Ooh, 7 was so close. I just knew she had said 7. Okay. Let's go to question 7. What's the time? 3:50 until 5:05. Yeah, that's 5:15 for them. What time is this class let out?
5:05. 5:05.
Okay. Okay, yeah, I'm gonna send it in. I think they said 7, right? Determine whether the following equation represents y as a function of x. Okay, so for this one, right, if we were to solve for y, we would subtract the x to the 7 from both sides, and then we would have to take the 5th root. Now, if that were an even number, then I would say no, but because it's to the power of an odd number, and when we do the 5th root, it'll stay a function, So I'm gonna say yes here. I don't really. I mean, I could try to explain that another way. Let me know if I need to. I know that was a little bit quick. Let me know if I need to explain that differently.
I have a question.
Go ahead.
So, if it's an odd number, like if the y is an odd number, it's an automatic yes.
Almost.
Okay.
Yeah, essentially it is. Like, I would still take it case by case and just kind of think about it. But but for this purposes, that's pretty safe, right? But still take it case by case and just think about it. But like if this were definitely even, like for instance, if that was to the power of 4, if we do an even root, whenever we do an even root, we have to introduce plus or minus, and that plus or minus is what causes it to not be a function, right?
Okay.
Because it's odd, we don't have to do the plus or minus.
Okay.
Let's see. Let's go open. Hey Google, give me a random number. Hey Google, give me a random number 1 through 21. Oh, somebody already took my 13.7.
Here's a random number, 19.
19. Close. Okay. No winners. Okay. Let's look at number 19. I think that's what we'll probably do tomorrow. I think that'll be appropriate. I wanted to take maybe. Let's be classwork. Okay. Refer to the graph. The graph of y in the figure. The x's are marked off in 1 unit intervals. Solve the equation when our y value is equal to 5. So y. Let's make this a little bit bigger. So y equals to 5 is here. Solve the equation. What is x when y is 5? Yeah, negative infinity up to negative 4, and then 4 to infinity. I will go e, because all of these have a value of y equals 5. I'm gonna go e. Hey Google, give me a random number 1 through 21.
Here's a random number, 12.
Ooh, close. I'm supposed to put close, but that's okay. I don't think anybody got 12. All right. So let's go to number 12. Find the domain, right? Anybody tell me the domain here? Or what's the answer? Or how do we solve this one? Okay, let's write it out.
Yeah.
So in general, for a rational function, the domain is all reals except any x that makes the denominator 0. So we have to throw out any x value that makes the denominator 0. Can you tell me the x values that make? So how are we going to find the x values that make the denominator 0 here? How are we going to find them? Set. So if we want the x values that make the denominator 0, all we're going to do is set the denominator equal to 0 and solve, right? Let me write this one out. So if we're doing, this is number 12. This comes from 1, 3, 29. We have this f of x. We got x squared minus 6x plus 5, or under x plus 5. So we're trying to see, okay, what x values do we have to get rid of? So we're going to set the denominator. Again, we're going to set the denominator equal to 0. So then that's going to be the x squared minus 6x plus 5 equals 0. Okay. So then what technique are we going to use here?
We're going to factor it.
Okay, we're going to factor Two numbers that multiply to give us what?
Is multiply to 6 and add to 5, right?
You got it backwards. So multiply to 5 and add to 6.
My bad.
1 and
It'll
5.
be 5 and
Right?
1, right? Or negative 1 and 5.
Negative 1 and negative 5, right? And then so then x is going to be 1 and 5. So those are the ones that we have to throw out. X equals 1 and x equals 5. So then if we have to throw out x equals 1 and x equals 5, which one is correct? A, B, C, or D? If we have to throw out x equals 1 and x equals 5, which is correct?
Would it be
E.
B?
No.
Okay, let's go this way. So if we have to throw these two out, right, what we're saying is everything is going to work except these two, right? So let's look at those two on a number line. That's right. Did I lock the meter? I think somebody was okay. So here's our 1, here's our 5. All right, we're saying it can't be this one and it can't be this one. So it's going to be everything except those. So that means we're talking about all these numbers going this way, all these numbers between these two, all these numbers going this way, right? So then if we want to exclude the 1 and the 5, we're going to use parentheses, all right? But parentheses mean we get really, really close to that number, but we don't ever include that number. So if our graph is like that, can we identify the answer now? So here, let's translate our graph, right? So if we write this graph in interval notation, the far left is negative infinity, and it goes all the way up until 1. Then we're talking about all the numbers from 1 to 5, and then we're talking about all the numbers from 5 to positive infinity. What kind of symbol does infinity always get in this context?
Parentheses?
Infinity always gets a parentheses. And what kind of grouping symbol do the 1 and the 5 get in this case?
A bracket.
Why did you say bracket over parentheses?
Because it's not the infinity. So like when I do that, I know, okay, if it's not infinity, it's a bracket.
That's not what those symbols mean. All right? The symbol, remember, parentheses means we get really, really close to that number, but we do not include that number, right? Parentheses in this context means we get really, really close to negative 5. I mean, like really, really, like no matter how far you zoom in, you can always find an infinite number of points, but we do not include 5. Bracket means we get really, really close to that number, and we do include it. So if that were a bracket, that means we would include the 5, right? So the only difference between parentheses and bracket, parentheses, we don't include that number. Bracket, we do include that number, right? So let's go like this, like this, like this. Okay. So, and then the proficiency with these terms, it just gets better with repetition. It gets better with repetition. We just have to kind of get our repetition on. Okay.
Master Pfeiffer,
Go ahead.
like it may be kind of babyish, but an easy way to tell the difference between the two, would it be parentheses is like the green light, and then the brackets like the red light?
What do you mean green and red?
Like, because you said when it's green light, you keep going, and because it's infinite, like it never ends, it's always going. But the bracket, it's like where it stops on the graph if you were to graph it, or like if you the line.
No, that doesn't work. Kind of, but so when you say it keeps going, you make it seem like it's unbounded. This is bounded. Like this doesn't go past 5. Like if we didn't have, for instance, say we just had that far right. Oh, you can't see it. Let me go back. Say we had just the far right, right? That the way you kind of described it, it doesn't match this image, right? Because when you say green means keep going, it's almost as if you're saying it keeps going this way, and that's not what the symbol means. So when I'm saying it's infinite many points, like if we were, like for instance, at this level, like the 6 might be here, this might be 6, this might be 7. so on and so on, like that, right? And so we could actually zoom in. We could zoom into this little area right here, and like this point could be like 5.0000001, and if this was 5.00001, we'll still have an infinite number of points no matter how far we zoom in, and it'll never still touch the 5. So we can zoom in and still have a whole bunch of points. But if it was drawn like this, we would never get to the other side. It's not going to keep going this way. Right? I just don't want you to think that it keeps going like this. Does that make sense?
Yeah, I get it.
Yeah. And I'm glad we're having this discussion, because like this is why I keep asking questions, because it's like until I get feedback, I don't know what you guys are thinking. I can kind of guess, but not until you respond. Then I was like, okay, I know where they are. So again, parentheses just means we never reach that thing. When we're doing infinity, we never reach infinity. So if we were talking about infinity, yeah, it just keeps going forever in that direction. But for parentheses in this context, it doesn't just keep going. It is bounded, but it also never reaches 5. It's really strange, right? It's like zooming in versus just continuing, being unbounded. There's a difference between being bounded and unbounded, and I can't think of the analogies, but hopefully that kind of sheds some light on the idea. We're going to keep working it until it kind of sinks in. Yeah, but yeah, let's let this one be. It should be C. I'm gonna go C. All right. Yeah, let's go C. Okay. All right. Let's try another one. Let's go open. Y'all make me nervous though. When y'all be getting my questions wrong, it makes me nervous. I'm like, are y'all doing my work? But it's okay. I'm not gonna, cause so the usual story for students is they just don't do the work. They try to finesse everything. Hang on with the numbers. Hang on. Typically, students try to finesse. Now it's different this go around because obviously we're remote, right? So obviously, Mr. Love, I'm not going to honor any of those results because you're not using your intuition. You're just trying to type as fast as you can. But when I started asking students direct questions and based on how you respond, I can kind of get a sense as if you've been practicing or not. It's going to show. I mean, you could try to finesse. That's on you. But sooner or later, that it comes around. It comes. So the best thing, I mean, I'm not really mad at that. We've all been there. I've been there. Just as long as you get it at some point, and hopefully sooner than later. Just be careful with the finessing energy. It will. Karma is real. It will come back to get you. That stuff catches up with you sooner or later. Okay, let's go ahead and open this up. Let's try another one. I'm gonna go. I'm feeling 8. Hey Google, give me a random number 1 through 21.
Here's a random number, 10.
10. Oh, forgot to type close. Get it. Okay, I got 8. Nobody got it? Oh, okay. I got it first. I don't see it. Oh, 8? Yeah, you got 8. Yeah, that's fine. But that wasn't the answer. Okay, let's go to 10. Domain, right? Okay, we just did this one, right? So, interval notation. I really want to offer some extra credit. I haven't updated my system to do extra credit yet. Can anybody tell me the answer here? Take some time, okay? I'll prime you though. Let me see. What's the time? We got out 4:05, so 4:55. Hey Siri, set an alarm for 4:55 p.m.
Okay, it's on.
So take some time. Not that much time. Hey Siri, set a timer for 5 minutes.
1 moment. Okay, your timer is set for 5 minutes.
So take some time and see if you can tell me the correct interval. I just want the final answer here. See, can you get this one? And I'll go like this so you can see it a little bit better. Hey Google, play some chill hop music from YouTube on the basement TV.
Okay, playing a YouTube music mix of chill hop music on basement TV.
Hold on. Let's do this. Hey Google, turn on the basement TV.
Sure, turning on 2 things.
And then let's try it one more time. Hey Google, play some chill hop music from YouTube on the basement TV.
Okay, the most hype hip hop and rap music mix 2020 from YouTube Music.
What?
Playing on basement TV.
I don't think he's playing what I want to hear right now. I mean, it might be okay, but that's not what I want to hear. Hey Google, play some chill hop music on the basement TV. I said it too late.
Okay, playing a YouTube music mix of chill hop music on basement TV.
Okay, that's better. Anybody get this? Okay, I see negative infinity to -6. Okay, this looks okay. Everything except plus or minus 6. Okay, let's see. Okay, let's type that in. So parentheses, I see negative infinity up to -6 cup. Then from -6 to 6 cup. And then from 6 to infinity. Okay. And you know, the finesse energy, it has its place. I mean, you know, every energy is needed. You know, I know this is a little bit of a stretch, but it is. I don't know that this place is here. Maybe it is. Maybe it isn't. I don't know. How what, Mr. Washington Jr.? How is every energy needed, or how do we get that answer?
This question. Yeah, like,
How do we get that answer?
Yeah.
I wish y'all could see each other's. Come on. Hey Google, reduce the volume of the basement TV. Hey Google, change the volume of the basement TV to 15%. Okay, let me take some notes here. So this is question number 10 from. Oh, that's not the right thing. And let's do this in black. So this is question number 10. It comes from 1325. And it says give the domain. I'm going to say domain and put a question mark. And then we have this g of x equals, we got this x squared minus 36 under x plus 7. So it is expected that we already know factoring for this. Again, if anybody's not comfortable with factoring, let me know, and I can give you some practice on it. We actually have like a scanned chapter of like problem sets and I think answers. We have access to it. It's on our Blackboard page, and it'll go through all the factoring scenarios with techniques that you'll come across in this course. It's a little bit a good amount of work. Maybe that's what we'll do on. We can do that tomorrow. Actually, I think that'll be good for tomorrow. To take some time to look at that factoring, just to kind of, review that. We can do that tomorrow. I think that'll be good actually. We'll do that. Thanks for that. So, but yeah, that's the whole reason why we meet with the extra time. So then when we see the openings or we see where the gaps are, we can actually take time and like fill those in. I know it's not going to be thorough, but we can at least try to address it on some level. So with this one, with the domain, again, in general for a rational function, the domain is all reals except any x that makes the denominator 0. So this is the same thing. We want to set the denominator equal to 0 and solve. Okay. So that means we got to set this x squared minus 36 equal to 0. So this is a special factoring scenario, right? This is a special factoring case. This is one of the 3 cases of factoring a binomial, and we're going to get an answer like the following. We get x, and then it's just plus or minus 6. Let's see. What was that one for? Was that halfway? I don't even know what this was. That's okay. Yeah, I don't know what that was for. Okay. Is this okay up until here, Mr. Washington Jr.?
Yeah, I got that, but I just don't know how you like put
Okay.
the answer together.
And then is this okay if I write that x equals plus or minus 6? Is this okay?
Yeah, that makes sense.
So then, if these two answers make this polynomial 0, and that means we don't want a 0 in the denominator, so we have to throw out the plus or minus 6. So then it's the same argument as the previous, right? We're saying that everything is going to work except plus or minus 6. So here's negative 6, here's positive 6, and we want to throw out these two, right? So we're saying everything is going to work except for those. So what we're saying is everything to the left here works, everything between negative 6 and 6 works, everything to the right of 6 works. Now we want everything except the 6's, so we're going to group those with parentheses. All right? So then if we, after grouping them with the parentheses, if we want to write this in interval notation, the far left is negative infinity up until negative 6. And then the middle part is negative 6 to 6. And then the far right goes from 6 to infinity. Infinity always gets parentheses. And in this case, because we don't want the 6 and the negative 6, they all get parentheses. And then we group it with this cup symbol. This is called union.
That makes sense now. Thank you.
Yeah, no worries. I just realized, so like this weekend was Labor Day weekend. Did they do Dragon Con? Any like anime people? Did they do Dragon Con at all this weekend? Because usually like there's a parade on the Saturday, and but I didn't hear or see anything.
I don't think so.
Man, that's sad. That's so sad. Because I mean, it's geeky, but it's fun. Like,
yeah, it's so fun.
It's fun. Like you could just go out there, and like if you just go on that Saturday morning, it's just basically everybody's in like costumes, like from anime and all sorts of stuff, all sorts of different locations. I mean, and it's just fun. It's just fun, especially like if you wear your own costume, then you run into others and like you take like group photos, and we feel like I have like Naruto. I have a Naruto costume, so I'm just a regular Jonin Leaf Ninja from Naruto. So then I would meet up with other Leaf Ninjas, and sometimes I battle the Akatsuki, and we do like little like quick little just photo ops or whatever. It was always just fun. It was just fun. But I thought about it. I was like, I don't think they're doing it this year, and I didn't even bother to look into it, because even if they were doing it, I wasn't about to go out there. As much as I want to be out there, I was just like, I don't know. I hadn't gotten resolved with this whole pandemic thing, whatever it is. I haven't gotten resolved with it yet, so I'm just trying to get through the winter. Okay, like Game of Thrones. I feel like I'm in Game of Thrones for real. The winter is coming. Go ahead.
Sorry to interrupt you, but I have a question.
Go ahead.
So when it comes to factoring, does like the plus or minus part matter? Because when I first started, I got minus plus, and that's what kind of threw me off. Because I saw your example when you went through it, you got plus minus.
That's the
so
same
like,
thing.
does the position of the
No, it doesn't
sign
matter.
matter?
It's the same thing.
No.
But when we write it out, it does need to be in increasing order. The smallest thing needs to be to the far left, and then they need to get bigger and bigger as you go to the right.
Okay.
So yeah.
Thank you.
Yeah, the plus or minus just means positive 6 and negative 6. But when we write it, when we submit the answer, it needs to be in ascending order. Okay. Okay, let's see. What's the time? We get out at 4:55. I still can't figure out why that alarm went off. Hey Google, give me a random number 1 through 21. Just got it in there.
Here's a random number, 11.
Ooh, close. Okay. Let's look at number 11. Did we do 11? We have not done 11. It seems like it's doing a pretty good job of not repeating the numbers. Find the domain, right? So there are two restrictions. Let me write this one out. I feel like this one is kind of fun. So this is question number 11. And we'll do some factoring, because this is like the end of exam 1 with this topic. So we'll do some factoring tomorrow. So this comes from section 1.3, question 27. And we have this, let me see, we got the square root of x minus 3 under 6x, right? And it says domain. We're trying to find the domain. Okay. So again, we have two restrictions going on. The first thing is we can't divide by 0, so the denominator cannot be equal to 0. And we're taking a square root, right? If we're doing a square root...
So that's why.
Huh? Oh. Okay, let's do it like this. Was that a question or you were talking to somebody else?
Yeah, y'all know it, right? I'm already knowing your ass past math composition 1 and 2.
Alright, let's try to mute. Come on. Let's go here. Maybe it's like this. There it is. I got it. Alright, I think that worked. Okay. So, if we got the square root of x minus 3, remember, we can't take the square root of negative numbers, right? So that radicand, now normally, the x minus 3 has to be greater than or equal to 0, right? But it can't be equal to 0 because it's in the denominator, so we actually have to scrap that equal to bar. We have to scrap that. Okay? So then it has to be strictly greater than 0. So if we solve, we're going to get x is strictly greater than 3, right? That should be it. So let's put this on the number line. Let's graph this result on the number line. Here's 3. If x is greater than 3, are we talking about the numbers to the left of 3 or the numbers to the right of 3?
To the right.
We're talking about the numbers to the right, right? So we're talking about every number to the right. Do we include the 3? Yes or no?
Yeah.
No, there's no bar.
You have a equal, right?
There's no bar, right? So we don't include the 3. So if we're not including the 3, does it get parentheses or does it get bracket? So
Parentheses.
it gets parentheses. One of the ways I kind of remember this one, I just go in my mind, I say, oh, if I see a bar means bracket. Right? That typically seems like it works. So if you ever see the bar means bracket. Okay. But in this case, again, we're not doing the bar because we cannot be equal to 0, so then it should be parentheses. So then we're going to write this graph in interval notation. The far left, what's the far left of this graph? As we trace this graph from, how far left does this graph go? How far left does it go? How far left does it go?
Up until 3.
3, right? So the far left is 3. The far left is 3. How far right does the graph go?
To infinity.
And beyond, okay? Infinity always gets parentheses. And in this case, the 3 also gets a parentheses. Because we get really, 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 really close to 3, but we don't actually reach the 3. Right? Okay. So the domain should be 3 to infinity. Anything to the left, anything 3 or left, pardon?
There wouldn't be a bracket on 3.
It's not going to be a bracket. Right? So remember, if we had a bar here, then we would be a bracket. But because there's no bar, there's no bracket. Hopefully that's okay. So the domain is going to be, it should be 3 to infinity for this one. So I'm going to do parentheses, 3 to infinity. Awesome. So that's good. Let me see what we're looking like on time. We can go for about 5 more minutes. Hey, Google, give me a random number 1 through 21.
Here's a random number, 18.
19 was the closest. All right. Okay. His name keeps popping up. He be getting them. I don't know. You're doing some kind of like meditating over there or something. All right. Let's look at number 18. All right. Use the graph to find the indicated value. So when x is 4, I don't know if y'all can see this or not. When x is 4, what's our y?
-1.
-1 sounds good. Let's go with it. Whoa. Hey Google, give me a random number 1 through 21. It's time. Oh, you beat me.
Here's a random number, 18.
Did we just do 18? You tripping. Let's go to the next question. Let's see what's the next one that we haven't done. Let's go to 20. It says the diagonal of a square tile is a function of the length x of a side of a square. Write a function rule for the diagonal of the square. Find and interpret d of 7. Okay. Let's write this one out. It says the diagonal of a square tile is a function of the... Okay, so we're doing a square. So let's start off with the square. All right, so I'm just going to draw a square. Man, that's close enough, I guess. Okay, so we have our square. And then it says the diagonal. Okay, so now let me see if I can get this to work. So it goes like that. If I click here, I can do style. And yeah, buddy. Oh, yeah. Can I make those more pronounced? That would be nice. Whatever. Nope. Yeah, that looks even better. Awesome. So the app I'm using, they just did an update. And I used to draw my dash lines manually, but now they made that a feature. They every so often they update and they make relevant updates. It's fun to me. Like, I'm actually kind of excited about being alive now because technology is scary, but it's also fun. Like when you embrace it. Like the gaming is way better than like when games first came out. Like when it was like PlayStation, it was like you beat the game and you'd be like crap. Then you didn't want to play no more. But now it's like live, and so like they update. And they make some minor little tweak, and it completely changes the dynamics of the game. You'd be like, crap, I got to learn this thing over again. But you never get bored. You know, only boring people get bored. At least that's what our mentors would tell me. And so, so in hindsight, that does sound kind of like a slam. But I know he wasn't talking about me because I was never bored. But yeah, so anyway, let's wrap this up. And this will be it for today. So it says the diagonal of a square tile is a function of the length x of a side of the square. Write a function... diagonal. Okay, and it's a square tile. Okay, let's hop over here. And then they ask us to find D7. Okay. So, if x is going to be the length of the side, that means since it's a square, this side is also length x. They want us to find D of 7, right? So first we need to find the function. Okay? This is going to be a 90-degree angle. How can we find the diagonal? I think it's Pythagorean theorem, right? It's a right triangle, right? What's Pythagorean theorem? How does that go?
A squared plus B squared equals C squared.
A squared plus B squared equals C squared, right? So then our D of X is going to be... Now we would take the square root and we should do plus or minus, but we're not going to do a negative in this context because we're not doing a negative distance. So we're just going to say the diagonal should just be the square root of 2x squared. That's good enough. Okay. So that function should be fine. So then let's find D of 7. Let's see if our function works. Let's see if we're functional. 2 times 7 squared. All right. 49, that would be what, 98? So that's going to be the square root of 98 is the distance. Let's see how they want their answer. I'm just going to put the square root of 98. Oh, wait. The function is the square root of 2x squared. Square root 2x squared. The diagonal of the product is this. The perimeter 4 area. The diagonal of a square is a function of the side. Write the function rule. Okay. So maybe the square root of 2 times the absolute value of x. That's the only other thing I could see that might be different. Let's rewrite this because I think what we have is fine. I think we're just not using the right format. I'm going to leave it as the square root of 2 when we do the square root of x squared, that's actually absolute value. So I'm going to try this as absolute value and see if that works. Square root of 2 times the absolute value of x. Let me put my multiplication in there too. Just to try to bring it on home. Let me think about it. Okay, before I do my final check, I'm going to go view an example because I know it's formatting is the trouble here. That's the perimeter. Write a function that means that's perimeter. But we're not doing perimeter, are we? We're doing a diagonal. Let's continue. That's perimeter. Stop. Why is that different? The diagonal of a square tile is a function of the length side. Write a function for the diagonal of the square. Interpret d of 7. Square root of 2. Okay, I'm going to lose the absolute value and see if that fixes it. I might be too precise. Let me see what happens there. Yeah, see, we had it right. We weren't getting the right form. So the only difference was we split apart the 2 times the x. Square root of 2, you see it persisted. The square root of x squared, even though it should be absolute value of x, it just square root of 2, they cancel. Square root of x squared, the squared and the square root cancel, and it left with just the x. Okay, so that's where this came from. And then, so it's going to be round to 3 decimal places. We need a calculator. It's 7 times the square root of 2. I'll just use this one. I don't really feel like doing it. Okay. 7 times the square root of 2. It says 3 decimal places. 9.899. 9.899. Yeah. Okay. I think that's it. What does this value mean? Okay. The diagonal of a square whose side length 7 is about equal to this value. Yeah, that sounds right. The length of a side of a square whose diagonal is 7. The diagonal is not 7. The side is 7. So this should be A. All right, gentlemen. If there aren't any burning questions, I'll let everyone go. I'll see you tomorrow. We're going to do some factoring tomorrow. Whenever we have downtime, I think I might come back to this factoring. We'll see how it goes. Okay?
I'm just a Viper.
Yes, go ahead.
Do I like purchase my books on Pearson or just go to the bookstore?
Pearson will probably be better for my course. Just purchase it directly from Pearson. It'll give you an ebook and access to all of your assignments.
I got you.
All right. Yep. Any other questions from anybody? All right, guys. I'll see you tomorrow.
You to go, Professor.
Take care.
We see you tomorrow. Go, Professor P.
I'm just a reflection of you, brother. Just a reflection
I
of
got
you.
one question.
Go ahead.
So I just ordered my book from Morehouse,
Mhm.
and I don't know when it's coming yet. At Morehouse, it doesn't tell me, like, give me a tracking.
Yeah.
So my Pearson, it just expired. So what should I? I wanted to wait for my book to get here because I didn't want to pay the $104 if I knew the book was coming with the code. So what should I do?
So you can make another account and just to be practicing, but then once you get access back to your main account, you'd have to go back to those assignments.
Okay.
Yeah, that's the only way. But you can make another account. Basically, you can keep everything the same with a different email. But once you get access to your full account, just go back to those assignments because you don't want to like not be working. That's a recipe to get behind.
Okay.
Right.
So to make another account, how will it still be saved? Like all my finished stuff be saved?
Yeah, it'll be saved in your original account, and so whenever you get your code, go back to that account, activate it, and then that way you can keep all your that work. But just in the meantime, you're making that account just so you can be practicing.
Okay.
So you don't fall behind. Yeah.
Thank you.
Other questions, gentlemen?
Yeah, quick question, Professor. So after we do the exam, we don't have any homework for this week?
Not for this week, but I think I loaded all the assignments for the semester shy of exam.
So I can just, go ahead.
Yeah.
Because I finished my exam yesterday. I just wanted to know if I could,
Yeah, if you want to go ahead, you're more than welcome. That's why I went on and loaded it. Yeah.
All right, cool. All right, you have a good one.
You as well. Any other questions, gentlemen? You okay? Going once, going twice. Okay. Thank you, guys.